Hello guys, you are welcome once again to Properties of Natural Numbers on my YouTube channel Let's Learn Maths. The first episode, we took a look at natural numbers that are also called counting numbers, and then the second one we looked at was whole numbers. So today we are going to continue from whole numbers. Since whole numbers was number 2, now we move on to number 3, which is going to be even numbers. So repeat with me if you're watching. Even numbers. Even numbers. Numbers that are even. One may ask, what are even numbers? Even numbers are the numbers that are divisible by the number 2, and also even numbers are multiples of 2. It is very simple. So when you are writing down the multiples of 2, the multiples of 2 that you are writing down are even numbers. And also, if a number is divisible by 2, then that particular number is also an even number. Let's go to the board and let me give you an explanation. Even numbers are divisible by 2. Let's take that particular one. So all even numbers are divisible by 2. How do you know that this number is an even number? You will know that a number is an even number if the number can be divided by 2 without any remainder. So for instance, for example, if we have a number such as 20, how do we know that 20 is an even number or it is not an even number? We simply have to take 20 and divide it by 2. If 20 is divided by 2 and there is no remainder, then 20 becomes an even number. So let's go to the board and have a look at it. So 20 divided by 2. In both cases, when you divide 20 by 2, the answer is 10, right? So over here, 20 divided by 2, we get 10. 20 divided by 2 is the same 10. So, do we have a remainder? No, there is no remainder, meaning the number 20 so therefore 20 is an even number. Why? Because 20 was divided by 2 and we had the quotient, the answer to be what? 10. Was there any remainder? No, there wasn't. So 20 is an even number because when you divide 20 by 2, there is no remainder. Hence, 20 is an even number. I believe I've made myself clear. You can take a different number. Again, 100. How do you know 100 is an even number? Divide it by 2. If you divide it by 2 and there is no remainder, it tells us that 100 is an even number. So we take 100 divided by 2, or 100, divide it by 2. What do you think will be the quotient or the answer when you divide 100 by 2? It's definitely going to be what? 50. Since 100 divided by 2 gives us the quotient or gives us an answer 50 without any remainder, we can say that 100 is an even number. Period. So 20 is an even number, 100 is also an even number. Why? Both numbers are divisible by 2. When you divide them by 2, there wouldn't be any remainder. I believe you are with me. Are we making progress? Good. Let's take another example. Let's say our next number is going to be 41. So when you take 41, divide it by 2, or 41 divided by 2, what will be the quotient or the answer? Someone will say 20 and a half. Someone will say 15 and a half. I believe you know 15 and a half is wrong. But we all know that 20 and a half is correct. So when you divide 41 by 2, it is going to be 20. The whole number will be 20. And when the 1 is also divided by 2, you are going to have half. When you divide 41 by 2, you get 20 whole number. And the remainder is 1. Since 41 divided by 2 gives us a whole number 20 and a remainder 1, we can say that 41 is not an even number. Why so? Why is it so that 41 is not an even number? It is because when you divide 41 by 2, you get a whole number, which is 20, and 1 will be left, which is the remainder. Most often than not, we don't divide the 1, because when you divide 1 by 2, you get a common fraction or a fraction part or decimal fraction part. But we need the whole number to tell us whether 41 is an even number or not. But over here, when we divided, we found out that 41 divided by 2 will give us 20, remainder 1. Hence, 41 is not an even number. Remember, when we divided the first value, we got a whole number. The second value, we got a whole number. But over here, we have a whole number and a remainder of 1. That is why we are saying 41 is not an even number. I believe we have made progress. Good. Let's take another example and move on. Even numbers are divisible by 2. So now let's go on and then take a look at even numbers are also multiples of 2. So all even numbers are multiples of 2. All even numbers are multiples of 2. When you are writing down the multiples of 2, you begin from the number 2. You begin by writing down 2. And then the subsequent or the next even number will be found or will be obtained by adding 2 to the previous even number, because all even numbers are multiples of 2. So in demonstrating this, we have 2. To find the next even number, you add 2 to this, and we have 4. To find the next even number, you add 2 to the 4, then you have 6. Then 8 and 10 and 12 then 14, then 16, then 18, and it goes on and on and on. So all these numbers are even numbers. Why? Because they are multiples of 2. So every multiple of 2 is an even number. So 20 will be an even number. Why? Because the next value over here will be 20. Supposing we have 3 over here, 3 is not going to be an even number, because when you are writing down the multiples of 2, you are not going to have 3. It won't exist in the multiples of 2. I believe you understand. Good. So all even numbers are multiples of 2, and all even numbers are divisible by 2. I believe you are with me. So this represents even numbers. When you are listing even numbers, you begin from 2, then you add 2 to the first even number, 2, then you have 4, you add 2 to the 4, then you have 6, so 6 will be the next even number, add 2 to the 6, then you have 8, 8 will be the next even number, add 2 to the 8, then you have 10, then 10 will be the next even number, and it continues in that particular order. We can boldly say that all even numbers may end with a 0, a 2, a 4, a 6, or an 8. All even numbers may end with 0, 2, 4, 6, or an 8. Why am I saying that? Take a look at all the numbers here. 2, 4, 6, 8, 10, 12, 14, 16. When you take 2, it is 2. So it is divisible by 2, and it's a multiple of 2, so it's an even number. 4 is an even number, 6 is an even number, 8 an even number. When you move on to 10, it is ending with 0. So when a number is ending with 0, it is definitely an even number. When the number ends with 0, it is definitely an even number. Again, when the number ends with 2, it becomes an even number. The last digit, when the last digit is a 0, or when the last digit is a 2, the number automatically is an even number. So over here, the last digit is 2, so it is an even number. Here, the last digit is 4, so it is an even number. Here, the last digit is 6, so that is also an even number. And then over here, the last digit is an 8, and 18 is also an even number. I believe I'm making progress with you. So when the number is ending with 0, 2, 4, 6, or 8, the number automatically becomes an even number. Let's write that particular one on the board. So that is it. when a particular number ends with 2, 4, 6, 8, or a 0, then it is an even number. So all numbers that end with 2, 4, 6, or 0 are even numbers. When we are taking examples, we can say that 204 is an even number. Why? Because the last digit, the 4, makes it even. Every value that ends with 4 is an even number. And then you can give another example such as 1308. This is also an even number. 1308 is an even number. Why? The last digit is 8, and 8 is an even number. So automatically 1308 becomes an even number, because the last digit 8 is an even number. Then what about 1301? Is that one an even number? No, it isn't. Why? It is because the last digit is 1. And when I was giving the clues for identifying even numbers, I didn't include 1. When the number is ending in 1, it is a different thing altogether. It is not an even number. It is not an even number because the last digit is not ending with a 0, a 2, a 4, a 6, or an 8. I believe you understand me now. So this is not an even number, but this is an even number. And the next one, this is also an even number. So now I believe you can list examples of even numbers by using the clue that when the number has 2 at the end, or the number bears 4, 6, 8, or 0 at the end, then the number is an even number. So I can add this as an even number. 3000 will be an example of an even number. Why? Take a look at the last digit. The last digit is 0. And when a number has the last digit being 0, that particular number is an even number. When a number ends with a 0, the last digit becomes 0, then it means the number is an even number. I believe we have made progress under even numbers, and this has been the last thing added to the clues to help you to identify even numbers. Let's move on to odd numbers. Let's take a look at odd numbers. That will be number 4. So we have taken a look at natural numbers, whole numbers. We just looked at even numbers right now. And then the fourth one is going to be odd numbers. Odd numbers. And let me remind you, there is the second episode of properties of natural numbers. The second episode. So if you haven't learned the first episode, which we included natural numbers and then the whole numbers, then please do before you come and then learn something about the second episode on properties of natural numbers. If you don't know, then this is Let's Learn Maths channel on YouTube. Take a ride with me. We are drawing the curtains on even numbers, and we are going to continue with odd numbers. Odd numbers. That will be the fourth one. So we are going to take a look at odd numbers. Odd numbers. Now, odd numbers are the numbers that actually follow a particular pattern. They follow a particular pattern. I'm giving you clues that will help you to identify odd numbers. Now we know natural numbers. We've learned something about whole numbers. We've learned something about even numbers. Now we are tackling odd numbers. These are the clues I'm giving you for you to be able to identify odd numbers. Odd numbers follow a particular pattern. So that is one. So they follow a particular pattern. For instance, when we are beginning to list odd numbers, supposing we are listing odd numbers, we begin with 1. And when we begin with 1, we keep on adding 2 to the previous odd number to obtain the other odd numbers. So let's take a look at this. If you have the first odd number to be 1, then the next odd number can be obtained by adding 2 to the previous odd number. So we add 2 to 1. Then 1 plus 2 will give us 3. So the next odd number is 3. Then over here we add 2 to the 3 that we have. So it is 3 plus 2. Then the next odd number will give us 5 because 3 plus 2 is 5. The next odd number is 5. We continue by adding 2 to this 5 too. And then we have 5 plus 2. And then we have 7. So the next odd number is 7. Then 9, then 11, then 13, 15, 17. And it continues in that particular order. So the difference between the first odd number and then the second odd number is always 2. When you subtract the first odd number 1 from 3, the difference is 2. When you take the second odd number and then the third, and you subtract 3 from 5, you subtract the second odd number from the third odd number, which is 5 minus 3. The difference is also 2. So that's the constant difference between the odd numbers. So they follow a pattern and the difference is always constant. We start listing odd numbers beginning from 1. We keep on adding 2 to the previous odd numbers to obtain the subsequent ones. That is one thing we will have to note about or notice about odd numbers. They follow a particular pattern, and the pattern is very noticeable and very simple. So I believe I ended here, but the dots over here tell us that that is not the end of the odd numbers. They continue to infinity. They are infinite or infinite. They are infinite or infinite because they have no end, they have no limit. That is odd numbers for you. And then one thing that you will have to note or bear in mind is that always when you add 2 odd numbers, the sum will give you an even number. When 2 odd numbers are added, the sum is an even number. So when two odd numbers are added together, their sum is always an even number. Let's take the first two odd numbers. We have 1 and 3. So we have 1 and 3. Let's sum up 1 and 3. When you add 1 to 3, the sum is 4, meaning that 4, which is the sum, is an even number. So we have added the first two odd numbers and then we have the sum to be an even number. We have added the first two odd numbers and their sum is an even number, 4. You can see that on the board, which is 4. Let's take other two odd numbers. For instance, 5 and 13. 5 and 13. We have 5 and 13. So let's sum them up. What will be the sum of 5 and then 13? The sum of 5 and 13 can be obtained by adding 5 to 13, which will give us 18. And 18 is an even number. Remember, we learned that when you have a number and then the last digit is either 0, 2, 4, 6, or an 8, then that particular number becomes an even number. So adding 5 and 13, we have 18, which is also an even number. This proves that when two odd numbers are added, their sum always gives us an even number. So that is the second way to search, or that is the second way to find out whether a number is an odd number or it isn't, or it is not. So we have taken a look at one. Odd numbers follow a particular pattern. Remember, we list odd numbers by beginning from 1. So to obtain the next odd numbers, you add 2 to the previous one. You add 2 to 1, you have 3. Add 2 to 3, you have 5. Add 2 to 5, you have 7. Add 2 to 7, you have 9. And then it continues in that order. The difference between them is constant. The difference between 1 and 3 is 2. The difference between 3 and 5 is 2. The difference between 5 and 7 is 2. And it continues just like that. So I believe with this particular clue, we will be able to list other odd numbers as well. And then the second clue is when you add two odd numbers, their sum will give you an even number. And the examples on the board clarify, or they show that when two odd numbers are added, their sum will be an even number. Guys, I hope we are making progress under odd numbers. If there is any difficulty you are facing, any challenge, leave your comment under my channel and then I'll definitely take it and then give you an answer later on. So we are closing down the curtain on odd numbers, and then we'll move on straight and then look at prime numbers. Odd numbers and prime numbers are quite similar, though there is a thin difference between odd number and a prime number. Let's dive into looking at prime numbers.